All right, here we go. So before I go over today's portion, today's portion is actually really small and really short. So today is pretty much dedicated most of your time to taking the quiz and taking the unit test for the chapter. So not much to actually learn. But I didn't know if you guys wanted me to go over anything from the test outline. So I forgot to put it on the daily thing, like an hour ago. So I just put it on a couple minutes ago, so some of you might not even have a chance to see it yet. Essentially, there's going to be 14 questions, and I set it all up in Schoology. Only about half of you have taken that experimental test question that I put up a couple days ago. And the reason I put that test question on Schoology was for you to find out if you understood how to use the math keyboards. So absolutely try that out today if you haven't had a chance to try that. I think it says experimental test question or something like that. Testing out a test question. And its only purpose is for you to see if you know how to use the math keyboards. And you need to do that before the test Monday, because I think there's 5 questions on the test where you're going to have to type out your work in the test question. And then to be able to type out the work in the test question, you need to use the math keyboards instead of a regular keyboard. So that's kind of why I put that question up there, is for you guys to try it out. So it is actually pretty important to try that today, so that if you're not getting it to work, you can kind of ask me what to do, or give you guidance on what's going wrong, something like that. But otherwise, the test itself is going to be relatively straightforward. You know what? I forgot to write which ones are multiple choice. So let me put that on there right now. So 2, 3, and 4. I mean, not that it's going to change how you approach it, but just so you know. So there's 5 multiple choice questions on there. These 5 multiple choice are going to be worth less points than the other questions. And so this is just kind of a variety of style questions. I felt like the test last time took a little bit longer than I wanted it to, because it was kind of hard to plan these block schedule tests. And most of you finished it within the 90 minutes, no problem. But still, I don't usually plan a test so that you try to go right until the end. I'm not putting a time limit on this test, because I know some of you are going to take a little bit longer typing things in. So I don't remember which one of these other 9 questions are short answer, but I'm pretty sure it's 5 of them. So essentially 5 of them you're going to have to write out all the work. And the way that's going to go is you're going to write a line of work, a line of work, a line of work, and then make sure you write your simplified answer that you want corrected as the final line of work. And I kind of wrote that in the directions of the problem, but this is kind of how I expect to see it. And the experimental test question that I put up there for you guys to try out, some of you absolutely misunderstood what you were supposed to do. So there was a few people that were actually trying to solve the problem I put up there. And I'm trying to remember the question I wrote on there. I want to say it was 1 over x cubed root of x. Something similar to that. And what I did was I gave you the actual work and answers to the problem. So there were 3 lines of work you were supposed to do, or 2 lines of work and then an answer. And you were supposed to just copy down my information and write that down. Because the purpose of the question was for you to see if you could type it out. That's all it was. The purpose of the question wasn't for you to see if you could solve this, it was to see if you could take it out. So I tried to pick one of the more complicated ones that has lots of things, fractions, roots, cube roots, all sorts of stuff. So make sure you try this out today, because that's exactly what it's going to look like on the test. And that's kind of what I have to go by the grade. Do know, if all else fails, and you're trying to do the question on the test on Monday, and you just, for whatever reason, cannot figure this out, handwrite it down, and you can always message me a picture of the question, and we can go by it that way. So don't get too freaked out if things aren't working out. I get how it goes. I'm not going to punish you because things aren't working right. Do the best you can. It's quicker and easier for me to do it electronically. That's all. It's just more efficient. I still haven't been able to give you the worked out test from the last one, but I should be able to today. So the person who's going to make it up is trying to finish it up. So I should be able to post that today, and I'll send you guys a message when I do post it, so you can look at the correct answers and check it over with yours. Because of time constrictions here, I wasn't going to go through every one of these questions, but I'm going to guess by now you've had a chance to read through this. Is there one of these you would like me to discuss? Maybe it doesn't make sense to you, maybe you don't know how to find it. Anything. 4. Yes. So, continuity and differentiability at a point in an equation. So, let's just look at something straightforward and simple like this, which won't be the test question. But let's say this straightforward, simple one. I might ask you, is this function, or it might say something like, discuss the continuity differentiability at x equals 1. And at x equals 1, it is continuous, and it is differentiable. At x equals 2, it is not continuous, and because it's not continuous, it's automatically not differentiable. Now there's details that you're going to have to go from. So if you remember from continuity, to prove something is continuous, which you don't always have to prove, but there's a good chance that this information is part of the problem. Okay? So for continuity, you have to prove that the limit to the left, the function value, and the limit to the right are all the exact same. That's how you prove it's continuous. To prove something is differentiable, to be differentiable, it has to be continuous at that point, or x value, whatever you want to call it. So it has to be continuous at that x value, and the limit of the derivative to the left and the limit of the derivative to the right have to be the same. So basically, whatever equation you have, whether it's a fraction, whether it's a polynomial, whether it's a piece function, whether it's absolute value, you're going to have any kind of different equation. This is the information you're going to need to check either mentally or writing down. If I remember correctly, number 4, multiple choice. So on number 4, you're not going to have to show work. You're just going to have to be able to figure these things out from a problem. So like when I looked at 1 over x minus 2, the fact that it was continuous at x equals 1, I know that was the first one I brought up. The fact that it was continuous at x equals 1, and there was nothing there to change either of these, I immediately knew it was continuous and differentiable. Now, if absolute value, like the tip of an absolute value is a sharp point. So the tip of an absolute value, the derivative to the left and the derivative to the right of that sharp point are different. If it's an absolute value, but you're asked about where it's not a sharp point, well, then automatically the derivative to the left and to the right of this location are the same. So you're basically just going to have to kind of think about the equation you're given and look to see if there would be anything that would, not cause either of these. So the multiple choice answer on number 4, I think if I remember right, it's continuous, not differentiable. It's not continuous, differentiable. Continuous and differentiable. Not continuous, not differentiable. That's the multiple choice. So you're going to have to just figure out between the choices what's what. I hope that kind of clears up maybe what you're looking for, unless it was something else about the problem that you wanted. Okay. Yeah. Well, is there maybe a different question up here that somebody wants me to go through? Okay. If you're looking through this list sometime today, you can certainly send me a message and I'll get back to you. I will tell you that I 100% plan to shut off my computer and notifications after 3:30 today, so I can give my brain a rest too. I've been putting in a ridiculous number of hours lately, so I most likely won't answer anything over the weekend. But don't forget, you don't have to take the test Monday during class. Okay? So when you come to school, if you're coming to school or walking on Monday, you don't have to take the test during class hour. During the class hour, I'm going to reserve that time to just answer questions anybody has. And if you want to take the test during first hour, you can, because you'd be able to finish it during that time. If you want to review and ask some questions during first hour, you can. And then you can take the test at night. That'd be fine too. I don't have a problem with that. So, don't freak out this weekend if all of a sudden you run into something that you need a question on. You can ask me Monday too. So, even though I say the test is Monday, it's not like a normal setup where it'd be Monday during class. Okay, let's move on to do the normal part of Unit 2, Day 6, which nothing to do with the test. And let's do this. So we're going to talk about how to do the derivative of tangent. And how come we can now figure out the derivative of tangent. So basically, forever ago, once all those old people figured out how to do the derivative of sine and cosine, then they immediately figured out how to do the derivative of all 6 trig functions. And that's because, if you remember from pre-calc, all 6 trig functions can be written in terms of sine and cosine. So if I write tangent as sine divided by cosine, I can now find this derivative because yesterday we learned about quotient rule. So because this is 2 functions being divided, I can do the quotient rule on this. And we definitely need somebody to help me out here. John, we need a ringer, somebody to come in and just tell everybody what's what. How do we do a quotient rule again? Oh, sorry. How do we do the quotient rule? What's the first thing I should do? Perfect. Oh, yes. You're actually ahead of yourself because it sounds to me like you kind of do it in your head somewhat. And Yeah, no, that's okay. I'm going to guess most everybody else wants to set up this so that they don't have to do it all in their head. So F would be, but thank you, that was perfect what you were explaining. So F and G are the top and the bottom. And then you're going to do the derivative of sine, which is cosine, the derivative of cosine, which is negative sine, and then put everything in the correct place. So G times F prime. Oh, G. This is what happens. You think after teaching for 20 years I would be better at trying to write things while I talk. GF prime minus F G prime over G squared. And what happens is your numerator works out nicely. Because sine squared plus cosine squared is 1. And so the derivative of tangent, instead of writing 1 over cosine squared, would be secant squared. And this is how you could go through and figure out all 6 trig derivatives by doing the quotient rule on the other 4. Now, I'm not going to, make you guys go through and do all 4 quotient rules. But I will go over the derivatives with you because there's a pattern. But before I do that, I don't want to get... it's easy for me to get ahead of myself because I just kind of get talking about this stuff and I get excited, so I keep moving. Do you guys want me to go over parts of this problem that maybe you're not sure how come I wrote something? Alright. I can move on. You guys are pretty much like my 0 hour from last year. They were all so tired that they would just sit there and stare at me and never ask anything, even though they had tons of questions. I'm just going to write down all 6 trig derivatives for you. So if you are creating your own note card, do that. Now, officially, I know none of you are supposed to be using your own laptops. You're supposed to be using Chromebooks for everything. I'm assuming some of you are using your own computers. If you are, here's what I would fully recommend you do. Is, virtually every platform, Windows, Mac. I wonder if Chromebooks have them too. Do Chromebooks have little sticky note? Does it have a sticky notes app? Does anybody know? Because you might even be able to put it on your school Chromebook. Either way, use one of those post-it sticky note apps and kind of basically write your calc unit note card. And then that way, as we go over formulas, you can just add them in, like type them in so that they lay on the background. And when you're doing your homework, you can just kind of access it when you need it. And then you can make a new post-it or new sticky for each unit. And it's kind of a good way for you to review because you constantly see it and kind of keep it in the back of your mind. Okay, so I got distracted. Derivative of tangent is the one we just figured out. Secant squared. And then here comes the pattern. Because we just did derivative of tangent, what's the one we're probably going to do next? Cotangent. The answer for cotangent is going to be, can anybody kind of figure out the pattern from up above? Negative cosecant squared. Now, sine and cosine are the only one that actually kind of don't follow the pattern, but they do start the pattern by having positive, negative opposites. So there we had tangent and cotangent. Now we're going to have secant and cosecant. Now, the derivative to secant isn't great. It's secant tan. This is the worst one for you to memorize. But by following the patterns, you can figure out the other one. So we did derivative of secant. Now it's derivative of cosecant. And then the answer is going to be negative cosecant cotangent. So it is horrible to try to memorize all 6. But in theory, you only have to memorize 3. Because the other ones, the other halves, are basically like the exact opposites. They're the co-functions. Okay, this is technically everything for the unit. Like, this was the last part. The worst thing that you're going to run into, because I'll just kind of tell you this right now, which I am not putting as part of your unit test. The worst thing that you're going to run into is when you have to do quotient rule with a bunch of trig functions. And that's because your quotient rule is going to be made up of 4 things on the top, divided by something squared on the bottom. And you could have a combination of all of these different trig ones. And so then you have to figure out how the trig functions go together and simplify, which I know is the portion that you guys hated from pre-calc, which was the trig identities. So if you remember from pre-calc, you had to prove trig identities from one side to the other. And it was all about you like manipulating one whole side of the equation to make it look like the other. That's similar to what it's going to feel like when you do quotient rule with these trig ones. But that is not going to be part of our unit test yet. So I'm fully not expecting you to be like experts and pros at doing derivatives of all the trig ones. So if I ask you a derivative of these trig ones, it's going to be fairly straightforward. So I don't know. Is there anything, anything somebody wants me to ask me about for anything for the unit? So basically, I'll say by today, because my hope is that you guys are keeping the weekends to recuperate. But I know that's pretty much it. No wish. Yes, AJ. Just for trig is kind of what you're asking about? Ah, that's a good question. I'm going to be pretty lenient on it for right now. Eventually, you guys are going to do enough practice questions that you're going to get a feeling of what a multiple choice answer would look like. So the multiple choice answers are essentially how most things are simplified down to, and so that they look nicer. So I don't have a great answer for you other than do obvious simplifications. Like if you have like terms, combine them together. If you have something that can simplify, you should. Other than that, you don't really need to yet. I'm trying to think of examples that you would run into. If there's factors that could cancel, that's something that should be done. If something could be factored out, you should do that. But otherwise, I'm going to be pretty lenient on the test Monday because we've pretty much just started directives. And then you guys absolutely will get a handle on it because you're doing practice questions that you see how things should be done. If it's a multiple choice question, then it's obvious how far you have to simplify because the answer's there. But I'm very responsible. I mean, like, it wouldn't be a terrible idea for you to, well, honestly, I guess I hadn't really even thought about that yet. So there's three kinds of questions on the test. There's multiple choice, which is just going to be a 1 point question, right or wrong. So honestly, work isn't that. I mean, it's not going to affect your grade on that. The short answer, yes, the work is supposed to be in the problem. So then obviously I would see that. But I guess what I hadn't really planned on is there's going to be like questions that have a number answer that are kind of the auto-graded questions. I'm sure you've done some of them in the past. I guess I didn't think about those because those are more than 1 point. And I'm not sure how I would get partial credit if I didn't see work. Maybe for just safety purposes, write work down on a sheet of paper and don't throw it away yet. So then that way I can figure out with Mr. Stouffer what we'll do. That's a good question. There's probably definitely going to be things that we didn't think about when we're trying to set stuff up this year. Okay. I guess I'm pretty much done.